Okay, problem 9 is to classify all the critical points. Right, remember, what are the critical points? So there are two types, right? First is called singular. Singular is when the derivative does not exist. Okay, let's say singular point x equals a, then at point a, the derivative does not exist. Okay, the second type is stationary. Stationary, let's say point b, then the derivative at b equals 0. So there are two types of critical points. So part A, we just figure out its derivative, right? Its derivative, it will be, okay, you do the calculation, it would be 1 minus x over square root of this. Okay, for x between negative 1 and 3. So for x between negative 1 and 3, so what about this bottom part? This bottom is negative x squared plus 2x plus 3, right? Which is just negative x squared minus 2x plus 1, right? Plus 4, which is 4 minus x minus 1 squared. So when x is between negative 1, right? So when x is between negative 1 and 3, right? This bottom is strictly greater than 0, right? So this part, it's not 0, so we don't need to worry. The top, it can be any number. So the bottom is always 0, which means this derivative always exists. Which means there's no singular point. Okay, what about the critical point? Critical point, you just have to let f prime x equals 0, then the top equals 0, so the stationary point is x equals 1. Okay, then classify it. Is it a local maximum? Is it a local minimum? Or it's none? It's not, right? It's a saddle point or it's anything else. So theoretically, we have to figure out its second order derivative. But here, for this part, we don't do that. We just figure out what about the derivative. When x is smaller than 1, right? The derivative, you can see when x is smaller than 1, 1 minus x is positive, right? The bottom is always positive, so the derivative is greater than 0. When x is greater than 1, the derivative is smaller than 0, right? Which means when x is smaller than 1, the function is increasing, right? This function is increasing. This function is decreasing. So when x is smaller than 1, the function is increasing. Greater than 1, the function is decreasing, which means this 1 is its local maximum, okay? Which means this is a local maximum. Okay, so this is the first way we can figure out, is it local maximum or is it local minimum? Okay, then let's do part B. Again, the derivative is half, right, minus 2 cosine x over 2 times half. So it is half minus cosine x over 2. So first, this is a continuous function. It always exists, right? So there's no, so f prime x always exists on the interval 0 to 2 pi, which means there's no singular point. Then what about the critical point? f prime x equals 0, which means your half minus cosine equals 0, right? Which means your cosine, this equals half. Okay. Which means your x over 2 is what? It's pi over 4. No. Cosine what equals half? Cosine pi over 3 equals half. Right. So x is 2 pi over 3. Okay, x is 2 pi over 3. Then, is this a local maximum or local minimum? So this is our stationary point. Is this local maximum or local minimum? We can figure out its second order derivative. Okay, we can figure out its second order derivative. So let's erase some part. Okay, what is the function's second order derivative? Right, it's the first order derivative's derivative. So this part is just half sine x over 2. Okay, then you can plug it in, right? What is the second order derivative when x is 2 pi over 3? It's half sine 2 pi over 3 over 2, right? So sine pi over 3, so it is square root of, right? It's square root of 3 over 4. It's positive. If the second order derivative, so if the first order derivative is 0, the second order derivative is positive, then x is a local, okay, then fx is a local minimum, right? If the first order derivative is 0, the second order derivative is smaller than 0, then fx is a local maximum. Right. So here, the first order derivative is 0, the second order derivative is positive, so your conclusion is that f 2 pi over 3 is a local minimum. Okay. Part C, it's very similar. Okay, the first order derivative it's this. The second order derivative is this. Okay, then this always exists, right? So first, no singular point. And what about the stationary point? You just let the derivative equals 0, which means this equals 0, right? So x is square root 2 over 3, which is 3 square root of 6 over 3. Okay, positive or negative? Positive or negative? Okay, so you have two stationary points, right? Then what about their second order derivative? It's positive this, the second order derivative 6x, right? It's 2 square root of this. It's greater than 0, right? Therefore, the first order derivative is 0, second order derivative is positive, so f square root of 6 over 3 is a local minimum. Right. What about the second order derivative of this? Right. It's negative 2 square root of 6. It's smaller than 0, which means f negative, it's a local maximum.